let's get started. Yesterday, I had given you information and you told me all the conclusions you could make. You marked everything you could on your diagram. That is the start of a proof. But that's not enough. What you need now are little connectors that connect all those thoughts you wrote down. All right, and I'm going to show you those connecting theorems, connecting postulates today, tomorrow, and Friday. First, because you're going to hear me say postulate, you're going to hear me say theorem a lot. All right, I believe we talked about theorem last unit. All right, I gave you a couple theorems. Those are facts that can be proved true, like linear pairs are supplementary, vertical angles are congruent. Those are all called theorems because they can be proved congruent. Pythagorean theorem, that can be proved true. All right, that can be proved true. Versus postulates, they're just accepted as true. All right, just accepted as true. So if you hear me go back and forth between postulates and theorems, that's the difference. Postulates, we just assume they're true. Theorems, we can actually prove that they're true. Okay? So moving on. Here's your first one. And I always show this one first because kids are like, are you serious? When am I ever going to use this? Oh, you'll use it. Don't worry. By the end of today, you'll be saying, oh, yeah, I see how this works. And it's called the reflexive property. Ready? Go ahead and read it through. A quantity equal to itself. Oh, really? Thanks for the update, Mr. Carlino, right? Thanks. A line segment is equal to itself. An angle is equal to itself. It doesn't, it's kind of like, all right, thanks. Appreciate that. You guys don't think you're ever going to use that, right? An angle equal to itself, as a segment equal to itself. Well, you will, and we will by the end of today. But that's called the reflexive property. And anytime we do a postulate, theorem, property, I'm going to put them up here at the board. So you can always look at them up here. When we take the unit test, because I'll have a bunch of these eventually listed here, I'm going to give you all these on a sheet of paper. Okay? Just for this unit test. That's it. Okay, no quiz on Friday. You're going to get them for Unit 3, Unit 4 test. You won't get these, but I will give you a sheet of all these theorems and postulates at the end. All right? Next one. And you guys have been kind of doing this algebraically for a while. If I say 2x minus 6, and I tell you x equals 4, what are you going to do with that 4? Substitute it in, plug and chug, right? Well, you can do the same thing geometrically, except for segments and angles now. Take a look at my statements and reasons that I have here. I'm telling you AB is twice the length of AD, and AD is the same measure as DB. Do you see anything I can substitute in? Go ahead, read it through here. AB is twice the length of AD. Well, AD is also equal to DB. So what can you tell me here in my next statement by substitution? Take a look at it. It's kind of like 2x minus 6 and x equals 4. You plug in 4 every time you see an x. All right, what can I plug in now up here? And I like the hands, but I just want to hear from a random person here. Anybody have 27 in here? No? Too high? Okay, we'll go back to 7 then. 7? Good, there you go. Take a look what Evan just did. He knew AD was equal to DB. So he took DB, and everywhere he saw an AD, he substituted it in. And once again, Evan, what did you just tell me again? AB equals 2 times the length of DB, using what we call substitution. Okay. Let's do one more. One doesn't make you great. Let's do a second one here. Take a look at what I've given you. Angle A plus angle B is equal to 90. A and C are equal. What else can you tell me now by substitution? By substitution, what can you tell me now? Take a look. A plus angle B is 90. A and C are equal. Therefore, what can you tell me using substitution? 22? Joanna, go ahead. What? There you go. She took angle C because it's equal to angle A, substituted it in, rewrote it with angle C plugged in. And again, the reason I can do that, substitution. the substitution postulate. How we doing here? We all right? Any issues? Okay, next up. So far we have reflexive, substitution. They're coming on pretty quick here. Next up, addition. If you add two equals to another pair of equals, the sums are equal. Here's what I mean right now. What I'd like you to do right now is draw me two line segments that are the same length. Just freehand it right now below this proof. Below this proof, draw me two line segments that look equal. What I'd like you to do right now is label one of them A and the other B. Same length. Draw me another pair that are congruent, but not congruent to your first pair. And call those C and D. Here's what addition says. These two are equal, these two are equal. If I have two pairs of equal quantities, I can take two of them added together, and it'll be equal to the other two added together. Does everyone agree with that statement? Put these two line segments together, it'll be the same as these two line segments in length. We agree with that statement. Okay, so pick two for me here. Here we go. Who's got 9? 9? Look at that. Here, let's go. 20. 20? You want to pick A and C? Okay, so A plus C is the same length as B plus D. Is that the only statement I could have wrote up there that's true by adding? Ella, you're shaking your head no. Why? C plus B, yep. There you go. Does everyone see how that's true by what's called addition? Now, before we go on, and I make a huge, big scene out of this, if you would like to use the addition postulate, you need, ready? 2 pairs of equal quantities needed. That's a huge mistake kids make. You need 2 pairs. Everyone see it? Hey, first pair, second pair. Does everyone see? When you want to use the addition postulate, you need 2 pairs of equal quantities to add together. If these two are congruent and these two are not, we cannot use addition. Do we see that? You need 2 pairs of equal quantities. Questions about addition? Going up on the board. Already, look at this. We're only 10 minutes in. We got 3 of them already that are going to go into our proofs now. Questions, comments, any concerns? Oh boy, everyone ready for the big moment right now? Your first proof. Huge moment. Get some lights here. Huge moment, your first proof. Congratulations, everyone. You're at this moment. Let's see what you can do with it now. Here is how every proof will be presented to you before we do this one. I will give you information that's true, like yesterday. I will give you information that's true. I am asking you in a proof statement to show me that this is true somehow. How are you going to go from here to here? Your knowledge of all the vocabulary from Unit 1 with maybe some of these connected. It's like a puzzle right now. Here are the pieces and what you know. Somehow you got to finish the puzzle and show me that's true. Okay? Here's how we're going to attack this. What did I have you guys do yesterday? Very first thing I had you do when you read the givens was do what? Mark the darn diagram. That's exactly what we're going to do here now. Ready? AB equal to DE. I can put my hash marks. DBC equal to EF. It's marked. Okay? This is already done for you, but your first statement is always the givens. And your reason is why it's true, it's given. Okay? It's not up here, but please make sure statement 1 matches up with reason 1. We are going to be organized with this, so I can grade it very quickly here, and I can read all your writing. Okay? So your first statement in every proof should always be your givens, and the reason why it's true, it's given. Okay? Now you guys have to take over. Okay? You guys got to be the puzzle solvers now. How can I know that AB and DE being equal and BC and EF being equal will somehow make AC and DF? What you know, some of the connectors over there we've already talked about. How am I going to get these whole line segments equal to each other, knowing those two pairs are congruent? How am I going to do it now? Well, ready? What do I have to do to these two to get to AC? What do I have to do? Add them up. What do I have to do here? Add them up. So you're saying I'm going to have to use addition here. Okay, fine. How many pairs of equal quantities do you need to use addition? What did we just write down? If you want to use addition, how many pairs do you need? 2. How many were I given? 2. We're good. We can use addition here. All right, we can use addition. Ready? So we've said, all right, this is going to be an addition proof. Perfect. Tell me what you're adding together. What are you adding together here? You cannot go right to here yet. No. Addition says, show me what you're adding. Juliana, let's roll. What are we adding together? AB plus BC. DE plus EF. Why is that statement she just told me true? Because of the addition postulate. And that is what's going to go in my reasons. Well, that's true because of addition. We are not done yet because we were asked to prove AC and DF are equal. This should be the last line in my proof. Your proof statement should be the last statement. So the question is, how do I go from where we are right now to this part here? Well, everyone tell me. Somebody want to give me another name for AB plus BC? AB plus BC. What's another name for it? AC. Give me another name for DE plus EF. DE plus EF. What's another name for it? Anybody know why that's going to be true? And don't make something up we haven't done yet. Frank. Oh, a little thing, right? What did you guys just do? You took this and substituted in AC, what it's equal to. You took DE plus EF, substituted in DF. So there it is, substitution. How about that, huh? That's just 3 steps. Sooner or later here, you guys will be up to 8 to 9. All right, but for now, it's only going to be probably 3, maybe 4 steps for now. Ask away here. Anything you want to ask right now. Go ahead. Okay, ready? Give me another name for AB plus BC. So I substituted that in, right? Give me another name for DE plus EF. I substituted it in now. Okay? Questions? Let's see if this becomes any easier. We start catching on a little bit. All right, use the same picture for examples 2 and 3. All right, everyone take a look at the givens. ADF equals angle CBE. What can we do now? Start marking. What am I going to use hash marks here? Nope, we're using what? Arc marks. Go ahead, let me see you mark your diagram now. You have 2 pairs of angles that are congruent to each other. Go ahead and mark them, please, appropriately. So a single arc mark, double arc marks. And if you want to get going right now, you know what the first statement's going to be, your givens. And I don't care what you do in your, listen, whoa, hold on. I don't care what you do in your notes, in your homework. This will never fly on any test or quiz. Not in here, it won't. You write it out, please. All right, write out. I don't care what you do on your notes or in your homework, but that's not going to fly in here on test or quiz. You're better than that. Okay, look at what you're given, and then look at what I'm asking you to prove true right now. You know these pair are congruent, this pair right here are congruent. And we're trying to prove ADC. Everyone locate ADC, follow the letters. Everyone see ADC, congruent to ABC. ABC. So based on these angles that I'm given right now, congruent, how can I get to the bigger angles, ADC and ABC? What am I going to have to do to those given angles to get to those proven angles that I need? Oh, did I? Come on. All right, we're still going. All right. 20, no, I guess we don't. 22. I'm going to add them. Does everyone see I need addition here? Are we at least at that step, addition? Okay, hold the brakes though. When you start saying to yourself, I need to use addition, next question you ask yourself, how many pairs of equal quantities am I given? 2. So can you use addition? Yes. All right, so when you guys start thinking I need to use addition, pump the brakes a little bit and say, well, how many pairs of equal quantities I'm given? If your answer is 2, go ahead and add. I just need to know what you're adding now, though. You say addition, but what are you adding? Ooh, number 6. 6. What are we adding in the back there, Stacy? ADC, oh, that's the whole angle here. I'm not looking for that, though. I'm looking to prove that's true. Remember, use the ones you've marked on your diagram already. Okay, so I'm adding ADF to what other angle? Which one? You want to add those two together, though. Look, ready? You just gave me ADF, this angle right here, and we need to get to ADC. So you gave me this one right here, and we're trying to get to the bigger one. So what must I add to this smaller angle to get to the bigger one? The one right next to it, which is what angle? DEC? DEC is not an angle. Okay, we're getting lost in the sauce here. All right, ready? Do you see how these two angles are congruent in these two? When I combine those two angles right there, don't I get bigger angle ADC? When I combine those two angles right there, don't I get bigger angle ABC? Okay, so going back to my question, what must I have added to this angle right here, which you gave me as ADF? What do I have to add to ADF to get to ADC? Right next to it. You put those two angles together, you get ADC, which is one of the angles I'm looking to prove equal. So what do I have to add to ADF? CDE. First, do you see the angles I'm talking about? How can ready? DEC is that right there. You got to go in the correct order for me. All right, naming an angle, you got to go in the correct order. Okay, because when you tell me DEC, I'm just following the letters that you told me in that order. All right, so let's see here. Let's redeem yourself now. Adding those two angles, how do I name those? FBA plus, what am I going to add to angle FBA? DB. I didn't hear the last one. DB. Okay, you want that angle right there. Name 3 letters in a correct order for me. DBF. Aren't we going? CB. Okay, CBF. We okay? We sure? Everyone all right on naming them? And then why am I picking those? Adding these two and adding those two. That's by addition. How do I get here, though? 11. Who's got 11? Well, calm down first. All right, calm down. What's another name? If I added angle ADF and CDE together, what do I end up getting? Angle ADC. And if I added FBA and CBF together, what do I get? Angle ABC. And what allowed you to do that? Substitution. Everyone all right? So everyone's thinking, oh, these are easy. I'll just write addition, substitution. This is pretty easy. Not anymore. All right, not anymore. Everyone, are we okay on this part before I change up the proof slightly? Because you're going to see a problem in the next one that we're going to run into. Okay, same diagram. So go ahead and mark your given. And you can write it in your statements. Well, right off the bat, anybody see a little difference between this one and the last two we've done? What's the difference right away here? Okay, line segments. Evan? There is a diagram. It's the one we were using for one job. It's only one given, right? Didn't I give you 2 givens in the last 2 proofs? Well, let's see if that has anything to do with this, why this one's a little change up then. All right, let's take a look. Everyone see line segment DE, same length as line segment BF. Do you see the line segments I'm trying to prove congruent? DF and BE. So my question is, am I getting bigger or am I getting smaller from the givens? That's my question. Am I getting bigger from here to here or smaller from here to here? What do we got, 12? You're getting bigger. Everyone agree? If I'm going to go from DE to DF, that's getting bigger. If I'm going to go from BF to BE, it's getting bigger. So I need to do what? If I'm going to get bigger, I need to add. All right? But we got a problem now. Pump the brakes before you add. You need how many pairs of equal quantities? 2. How many did I give you? Oh, that stinks. You can't add right now. You need another pair of equal quantities before you're allowed to touch addition. So that's our job right here. Where is that other pair? It's not given to us, so we need to find it right now. Here's how we find it. You're given DE, right? And you got to go to DF. What do I have to add on to that? Don't say anything. Don't say anything. I'll call on somebody. But you're at DE right now, and you got to prove DF. What must I add on to DE then? 23? What is it? EF. Everyone agree? Okay, I'm just going to write that over the side that I got to add on EF. Let's go here. You're given BF, and we need to get to BE. What do we need to add on? 13. What do we need to add on to BF to get to BE? FE, EF. Everyone agree? Oh, wait a second, kids. You're telling me I got to add on the same thing to both DE and BF. Is that what you're telling me? I got to add EF to both to get to that proof statement. Well, what do you know about EF and EF? Oh, they are. How do you know they're equal? By what property? Oh, that's when we're going to use it. That reflexive will give us that second pair of equal quantity we need to add. Okay, so we've noticed, everyone see we need to add EF to both segments. And what do we know about EF and EF? They're equal. So I got to write that second pair in right now, that EF is equal to EF by what property? Reflexive property. Now how many pairs of equal quantities do you have? 2. Can I add now? Can I add now? Use addition? Yeah, I got 2 pairs. So tell me what you're adding then. 11. Tell me what you're adding. And that's going to be the same length as? And again, what gives me the right to do that? Oh, not substitution. When you add, you do addition, right? Substitution will be our last one here. What's the same thing as saying DE plus EF? Rename it. DF. Rename BF plus EF. And all I'm doing is substituting in. So this was a 4-stepper right here. Okay. Questions? Yes, Carolyn. Yes, we're making the second we're making that substitution statement. Yes. No. Anything else going? Okay, I'll start walking around here, seeing how you're doing. Okay, remember you have all these up here to use. All right, I've asked you to do a couple proofs. So when you, just so you guys are aware, when you get down to 6, 7, and the rest of the homework, that's statements, reasons. Okay, so for 6, 7, when it says give and prove, you always set up your statements and reasons column. Okay, let's get going.